Example 3 says evaluate the definite integral from x equals 0 to x equals 3 of the square root of 2x plus 8 plus 7 dx. So we're going to go ahead and use some of those properties that we saw previously, and I want to split this up into two different integrals. So this is equal to the integral from 0 to 3 of the square root of 2x plus 8 dx plus the integral from 0 to 3 of 7 dx. And now that we have these two integrals, I'm going to go ahead and just calculate this integral first, and we are going to need to use u substitution. So I'm going to let u equal 2x plus 8, and then du will equal 2 dx, and I'm going to divide both sides by 2, so du over 2 is equal to dx. So now this integral I can rewrite as, this I can replace with du over 2. So it'll be from, and now it's slightly different when we're using u substitution because now our variable is in terms of u, and often we'll put question marks for the new limits of integration since we don't know what they are in terms of u. And you can solve them, but I like to go back in terms of x. So we'll have the square root of u du over 2, and then I'm going to take out the 1/2 and then rewrite it so that it has a power. And then that's going to equal 1/2 u to the 3/2 power times the reciprocal of the new power, which is 2/3, from u equals question mark to u equals question mark. And then that's going to equal 1/3. I'm going to substitute back in 2x plus 8 to the 3/2, and now we are evaluating that from x equals 0 to x equals 3. And that is going to be equal to 1/3 times 2 times 3 is 6, 6 plus 8 is 14 to the 3/2, and then minus 1/3 times 8 to the 3/2. So now we need to calculate this definite integral, and this one's a little bit easier to calculate because the integral of 7 is 7x, and then evaluated from x equals 0 to x equals 3. So that's going to equal 21 minus 7 times 0 is 0. So that's just going to end up being 21. So the final answer is going to end up being 1/3, and I'll just factor it out from both of those. 14 to the 3/2 minus 8 to the 3/2, and then plus 21. Now that's a pretty ugly answer, and depending on where you're doing your homework, it might require a decimal approximation. So if you throw that into your calculator, you should get approximately 30.9186. All right, so example 4 says evaluate the definite integral from x equals 6 to x equals 6 of 1 over x squared dx. I'm going to rewrite this as a power, so it's x to the negative 2 dx, which is going to equal, we increase the power by 1 and then divide by that power, and we're evaluating it from x equals 6 to x equals 6. And then that's going to equal 6 to the negative 1 over negative 1 minus 6 to the negative 1 over negative 1, which we don't really need to calculate what that is specifically, each of those terms, because they're the same number, and so that minus that is going to give us 0. And we also could have used the property to identify that from the beginning, since our limits of integration are the same value. So this is another illustration of one of our properties, but let's go ahead and just calculate these. But at the end of the day, they're the same integral except the limits of integration are switched. So they're going to be the same value except one's going to be negative and one's going to be positive. So let's see how this ends up working out. Let's calculate this first definite integral. So that's going to be 3x cubed over 3, which just ends up being x cubed. And that's going to be evaluated from x equals 2 to x equals 4. So that's going to equal 4 cubed minus 2 cubed, which is going to equal 64 minus 8. So that's going to be 56. And then this one will be x cubed evaluated from x equals 4 to x equals 2. So that's going to be 2 cubed minus 4 cubed, which is going to equal 8 minus 64, which is going to equal negative 56. So just as we predicted, they're the same value, except one is multiplied by negative 1. And that is illustrated in property number 4 of the table that we saw earlier. Example 5 says that show that the definite integral from x equals 2 to x equals 3 of 7x dx plus the definite integral of x equals 3 to x equals 5 of 7x dx is the same or equal to the definite integral from x equals 2 to x equals 5 of 7x dx. So let's go ahead and calculate these two, and then we'll calculate the third one and see if we add the first two, if they're equal to the third one. So I'll just call this 1, I'll call this 2, and I'll call this 3. So let's calculate 1 first. So that's going to be 7x squared over 2, evaluated from x equals 2 to x equals 3, which is going to be 7 times 3 squared over 2 minus 7 times 2 squared over 2, which is 9 times 7 is 63 over 2 minus 28 over 2, which is going to equal 35 over 2. Okay, let's calculate integral number 2. That's going to be 7x squared over 2 evaluated from x equals 3 to x equals 5. All right, so 5 times 5 is 25, and 7 times 25 is 175 over 2 minus, we already calculated that term, and that was 63 over 2, and then 175 minus 63 is 112 over 2. And let's add 1 plus 2. That's going to equal 35 over 2 plus 112 over 2, which is equal to 147 over 2. So hopefully, if we did this correctly, our third integral will be equal to 147 over 2. But let's see. So that's going to be 7x squared over 2 evaluated from x equals 2 to x equals 5. So that's going to be 175 over 2 minus 28 over 2, which is equal to 147 over 2. Yay! And these things are equal.